Okay, ladies and gentlemen, hello and welcome back once again. It is 4 o'clock Eastern Time on a Wednesday, and the last couple of years that's meant it's time once again for Hot Technologies. Yes, indeed, my name is Eric Cavanaugh. I'll be your host for today's conversation, and folks, we're going to talk about some cool stuff today. We're going to dive into the world of in-memory. The exact title is Into the Future, an on-ramp for in-memory computing. It's all the rage these days, and with good reason, mostly because in-memory is so much faster than relying on spinning disk. The challenge, though, is you have to rewrite a lot of software, because the software of today, most of it has been written with disk in mind, and that really changes the architecture of the application. If you design the application to wait for spinning disk, you just do things differently than if you have all that power of in-memory technology. So there's a thought about yours truly. Hit me on Twitter at Eric_Cavanaugh. I always try to follow back and also to retweet anytime someone mentions me. So like I said, we're talking about in-memory today and specifically about SAP HANA. Yours truly spent a lot of last year getting to know the SAP community really well, and it's a fascinating environment, I have to say. Hats off to the folks who run that operation and are on the front lines, because SAP is an incredibly good operation. And what they're really very good at is doing business. They're also great at technology, of course, and they've really put a heavy investment into HANA. In fact, I can remember it was probably about 6 or 7 years ago that we were doing some work for the U.S. Air Force, in fact, and we got someone from SAP to come in and give us an early look at the world of HANA and what was planned. And to say the least, the folks at the SAP labs have put a lot of time and effort into understanding how to build out this architecture, which is completely different, once again, from traditional environments, because you have everything in memory. So they're talking about doing both transactional and analytical on the same data in memory as opposed to the traditional way, which is to pull it out, put it into a cube, for example, analyze it there, versus transactional, which happens in a very different way. So this is an interesting space, and we're going to find out from another vendor, actually, IDERA, a little bit about how all that stuff is going to work and what the on-ramp is all about, frankly. So we'll be hearing from Dr. Bloor, our very own chief analyst here at the Bloor Group, Des Blanchfield, our data scientist, and then good friend Bill Ellis from IDERA. So with that, I'm going to hand off the keys to, actually I have to take it back myself. I have to hand the keys over to Dr. Bloor, who will take it away. So Robin, the floor is yours.
Okay. Let me just click and see if it works. Yes, it works. That's good. Yeah, as Eric was saying, the time that we first got briefed by SAP HANA is back many years ago now. But it was very interesting. That particular time was very interesting. We'd run into one or two companies that were, in one way or another, offering in-memory technology. It was quite clear that in-memory was going to come. And it really wasn't until SAP stood up and suddenly launched HANA. I mean, it was a shock when I saw SAP do that. It was a shock because I expected it to come from elsewhere. I expected it would be, you know, Microsoft or Oracle or IBM or somebody like that. The idea that SAP was doing was really very surprising to me. I suppose it shouldn't have been, because SAP is one of the strategic vendors, and pretty much, you know, everything big that happens in the industry comes from one of those. Anyway, the whole point about in-memory, I mean, we realized, we used to talk about it, that as soon as you actually go in memory, this isn't about putting data in memory. This is about committing to the idea that the memory layer is the system of record, is the, you know, as soon as you migrate the system of record to memory, disk starts to become a handoff medium of one sort or another. It becomes a different thing. And I found that was very, you know, I thought that was very exciting when that began to happen. So really, it's over for spinning disk. Spinning disk is now, it'll soon be existing only in museums. I'm not sure how soon that soon is, but it's basically, solid state disk is now on the Moore's law curve. It's already 10 times faster than spinning rust, as they now call it. And pretty soon it will be faster still, and then that means that the use cases for disk just get fewer and fewer. And the curious fact, traditional DBMS, in actual fact, a lot of traditional software was built for spinning disk. It assumed spinning disk. It had all sorts of physical level capabilities that were painstakingly programmed in order to exploit spinning disk, making data retrieval as fast as possible. And all of that is being washed away. Just disappearing, and then there was obviously a very I don't know, lucrative, I suppose, it'll be in the end, opening for an in-memory database that tried to occupy the position that the big databases, Oracle and Microsoft SQL Server and IBM's DB2 had occupied in the in-memory space, and it was very interesting to watch SAP come marching forward and do that. Let's talk about the Memory Cascade. It's just worth mentioning. It's also, the reason for mentioning this, the reason I threw this in really was just to let everybody know this, when I'm talking about memory here, all of these layers I'm talking about are in fact memory, but you suddenly realize when you look at this that this is a hierarchical store. It's not just memory, and therefore pretty much everything we learned a long time ago about hierarchical store also applies, and it also means that any in-memory database has to navigate its way through this. So let me just walk through it. On RAM itself, and it's been just getting larger and larger and larger, and it's now measured in megabytes, but you've got L1 cache, which is 100 times faster than memory, L2 cache, 30 times faster than memory, and L3 cache, about 10 times faster than memory. So, there's a lot of technologies, well, a fair amount of technology has adopted the strategy of using those caches as kind of storage space on the way to having things executed, particularly database technology. So, that's one influence. Then we've got the emergence of 3D Crosspoint and IBM's PCM. And it's almost RAM speeds is basically what both of these vendors are boasting. The use cases are probably different. The early experimentation with this is yet to be completed. We don't know how it's going to impact the use of RAM and the technology of in-memory database for that matter. You then got RAM versus SSD. Currently, RAM is about 300 times faster, but of course that multiple is diminishing. And SSD versus disk, which is about 10 times faster, as I understand it. So that's the kind of situation you've got. It's hierarchical store. Looking at another way, in memory, of course, is completely different. So, the top diagram shows two applications, both of them perhaps accessing a database, but certainly accessing data on spinning RUSC. And the way that you actually make things flow through the network, depending on what dependencies are around, is you have ETL. So this means that, data goes onto spinning RUSC and then comes off spinning RUSC in order to go anywhere. And to get anywhere, it goes back on to spinning RUSC, which is 3 movements. And bear in mind that memory can be 100,000 times faster than spinning disk. And you suddenly realize that taking data and putting it in memory makes that whole thing really quite different. So you might have thought what would happen would be on what's on the right here. You might have thought that in one way or another, the ETL would, in actual fact, just go from data to data in memory. But in actual fact, it might not do that. In actual fact, you might have the situation on the right here where 2 applications can actually fire off the same memory. Certainly an in-memory database could give you that capability as long as you got the locking and everything else orchestrated around it. So this doesn't just alter the speeds of things. This alters how actually you configure applications and hold data flows. So it's a huge kind of impact. So in-memory is disruptive, right? I mean, we should get that from what I said. In-memory processing currently an accelerator, but it's going to become the norm. It will be used, being applied according to application value, and that's therefore very, very interesting that SAP have actually come out with a version of their ERP software that's in memory. And latency improvements up to 3 orders of magnitude entirely possible, and actually even more than that is possible depending on how you do it. So you're getting huge improvements in speed by going in memory. And the upshot, SAP HANA's S4, which I've released, I think, well, people say it depends. People say it's still being released, but it was certainly released last year. It's a game changer given the SAP customer base. I mean, there's 10,000 companies out there using SAP's ERP, and all of them, pretty much all of them, are large companies, you know. So the idea of them all having an incentive to go into memory and to use their fundamental, because ERP nearly always is fundamental applications of the business that are running, is just a huge game changer, and they will be very interesting. But of course, that all sounds very good, but it needs to be configured intelligently, and it needs to be well monitored. It's not as simple as it sounds. Having said that, I think I'll pass the ball on to, who's this guy? Oh, Australian guy, Des Blanchfield.
Very funny. Always a tough act to follow, Dr. Robin Bloor. Thanks for having me today. So, big topic, but an exciting one. So I've chosen an image that I often conjure up in mind when I'm thinking about the modern data lake and enterprise data warehouse and my little gems of data. So here I've got this beautiful lake surrounded by mountains and waves coming at it, and the waves are crashing over these rocks. This is kind of how I mentally visualize what it looks like inside a large data lake these days, the waves being batch jobs and real-time analytics being thrown at data being the rocks. And when I think about it as a physical lake, it kind of brings back a wake-up call to me that you know, the scale of the data warehouses we're building now, the reason we came up with this coinage and the term of a data lake is that they are very big and they are very deep, and occasionally you can have storms in them. When we do, you know, we've got to resolve what's creating the storm. So in the theme of this thing, to me it seems that this siren call of in-memory computing is indeed very strong. And for good reason. It brings about so many significant commercial and technical gains that's a discussion for a couple of hours on another day. But the general shift to in-memory computing, firstly I just want to cover kind of how we got here and what made this possible, because it sort of sets the foundation of kind of where some of the challenges can lie for us and what we need to be cognizant of and thinking of. In our world of moving away from traditional old spinning disk holding data and being paged on and off disk and into memory and out of memory into CPUs, to now we're just removing almost one of those whole layers, being the spinning disk. Because remember, in the very early days of computing, architecturally, we didn't move for a long time from sort of the mainframe and the mid-range world of what we originally thought of as core memory and drum storage. You know, as Dr. Robin Bloor said, you know, the approach we took to moving data around a computer architecture didn't really change dramatically for some time, for a couple of decades, in fact. If you think about the fact that, you know, modern computing technically has been around, if you'll pardon the pun, for some 60-odd years, you know, 6 decades or more in its sense that you could buy a box off the shelf, as it were. The shift to new architectures really came about, in my mind, when we shifted out of the thinking around mainframes and mid-range of sort of core memory and drum storage architectures to the brave world of supercomputing, particularly the likes of Seymour Cray, where things like crossbar backplanes became a thing instead of just having one route to move data across the backplane or the motherboard, as it's called these days, and inline memory. You know, these days people don't really think about what it actually means when they say DIM and SIM, but SIM is single inline memory, DIM is dual inline memory, and we've gotten more complex than that since, and there are dozens of different memory types for different things, some for video, some for just general applications, some built into CPUs. So there's this big shift to a new way that data was stored and accessed. we're about to go through that same shift in another whole generation, but not so much in the hardware itself, but in the adoption of the hardware in the business logic and the data logic layer. And it's another big paradigm shift in my mind. But we got here, just briefly on how we got here. I mean, hardware technology improved and improved dramatically. We went from having CPUs with and the idea of a core sort of is a fairly modern concept. We take it for granted now that our phones have 2 or 4 cores and our computers have 2 or 4 or even 8 cores on the desktop and 8 and 12 and more on 16 and 32 even in the server platform. But it's actually a fairly modern thing that cores became a capability inside CPUs. And then we went from 32-bit to 64-bit. A couple of big things happened there. We got higher clock speeds on multiple cores, so we could do things in parallel, and each of those cores could run multiple threads. So all of a sudden we could run lots of things on the same data at the same time. 64-bit address spacing gave us up to 2 terabytes of RAM, which is a phenomenal concept, but it's a thing now. These multi-path backplane architectures, motherboards, once upon a time, you can only do things in one direction, backwards and forwards. And as of the days of the Cray computing and some of the supercomputer designs of that time are now sort of in desktop computers and common off-the-shelf sort of desktop-grade rack mount PCs, because really most of the modern PCs now sort of went through this era of mainframe, mid-range, micros, desktops, and we sort of turn them back into servers. And a lot of that supercomputer capability, that supercomputer-grade design, got pushed into common off-the-shelf components. These days, the idea of taking very cheap rack mount PCs and putting them into racks by the hundreds, if not thousands, and running open source software on them like Linux and deploying the likes of SAP HANA on it. We often take it for granted, but that's a very new, exciting thing. And it comes with the complexities. Software also got better, particularly memory management and data partitioning. I won't go into a lot of detail there, but if you look at the big shift in the last 15 or so years or even less, how memory is managed, particularly data in RAM and how data gets partitioned in RAM, so that, as Dr. Robin Bloor indicated earlier or alluded to, things can read and write at the same time without impacting each other, rather than having wait times. A lot of very powerful features like compression and encryption on chip. Encryption is becoming a more important thing, and we don't have to necessarily do that in software in RAM and CPU space now. That actually happens on the chip natively. That speeds things up dramatically. And distributed data storage and processing, again, things that we once assumed the stuff of supercomputers and parallel processing, we now take that for granted in the space of the likes of SAP HANA and Hadoop and Spark and so forth. So the whole point of that is this high-performance computing, HPC capabilities, came to the enterprise, and now the enterprise is enjoying the benefits that come with that in performance gains in technology space and technical benefits, and commercial gains because the reduced time to value is dramatically dropped. But I use this image of a story I read some time ago of a gentleman who built a PC case out of Lego, because it always comes to mind when I think about some of these things, and that is that it seems like a great idea at the time, and you start building it, and then you get halfway through it and you realize that it's actually really tricky to put all the Lego bits together and make a solid thing, and solid enough to put a motherboard and so forth in there to build a case for a personal computer. And eventually you realize that all the little bits aren't sticking together right, and you've got to be a little bit careful about which little bits you stick together to make it solid. And it's a very cute idea, but it's a wake-up call when you get halfway through it and realize that maybe I should have just bought a $300 PC case, but I'll finish it now and learn something from it. To me, that's a great analogy for what it's like to build these very complex platforms, because it's all well and good to build it and end up with an environment where you've got routers and switches and servers and racks, and you've got CPUs and RAM and operating system clustered together, and you put something like HANA on top of it for the distributed in-memory processing and data storage and data management. You build the SAP stack on top of that, you get the database capabilities, and then you load in your data and your business logic, and you start applying some reads and writes and queries and so forth to it. You've got to keep on top of I/O, and you've got to schedule things and manage workloads and multi-tenancy and so forth. This stack becomes very complex very quickly. That's a complex stack in itself if it's just on one machine. Multiply that by 16 and 32 machines, it gets very, very non-trivial. When you multiply it out to hundreds and eventually thousands of machines to go from 100 terabytes to petabyte scale, it's a frightening concept. And these are the realities that we're dealing with now. So you then end up with a couple of things that have also helped change as well, and that is that disk space became ridiculously cheap. Once upon a time, you'd spend $380,000 to $400,000 on a gigabyte of hard disk when it was a massive drum the size of something that needed a forklift to pick it up. These days, it's down to sort of 1 or 2 cents per gigabyte of commodity RAM, commodity disk space, sorry. And RAM did the same thing. These 2 J curves in both these graphs, by the way, are a decade each. So in other words, we're looking at 2 blocks of 10 years, 20 years of price reduction. But I broke them into 2 J curves because eventually the one on the right just became a dotted line at the bottom. You couldn't see the detail of, so I rescaled it. A gigabyte of RAM 20 years ago was something in the order of $6.5 million. These days, if you pay more than $3 or $4 for a gigabyte of RAM for commodity hardware, you're being robbed. The significant tumbling reduction in prices over the last 2 decades has meant that now we can move beyond disk space and straight into RAM at not just the megabyte level, but now the terabyte level, and treat RAM like it's disk. The challenge with it, though, was RAM is natively ephemeral. That means something that lasts for a short period of time. So we've had to come up with ways to provide resilience into that space. And so my point here is that in-memory computing is not for the faint-hearted. Juggling this very large-scale in-memory data and the processing around it is an interesting challenge, as I indicated earlier. It's not for the faint-hearted. So one thing we've learned from this experience with large-scale and high-density in-memory computing is that the complexity that we build begets risk in a number of areas. But let's just look at it from a monitoring and response point of view. When we think of the data, it starts out in disk space. It sits in databases and disks. We push it up into memory. Once it's in memory and distributed and there are copies of it, we can use lots of copies of it, and if any changes get made, it can be reflected across at memory level instead of having to go on and off disk and across the backplane. At 2 different levels, it goes in and out of memory. We've ended up with this hyperscale hardware platform that allows us to do this now. When we talk about hyperscaling, it's hardware at ridiculously dense levels, very high density memory, very high density counts of CPUs and cores and threads. We've now got very highly complex network topologies to support this, because the data does have to move across the network at some point if it's going to go between nodes in the clusters. So we end up with device fault redundancy becoming an issue, and we've got to monitor devices and pieces of it. We've got to have resilient data fault redundancy built into that platform and monitor it. We've got to have the distributed database resilience built in, so we've got to monitor the database platform and stack inside that. We have to monitor the distributed processing scheduling, what's happening inside some of the processes, all the way down to following a query and the path the query takes, and the way the query is being structured and executed. What does it look like? Has someone done a select star on Bloor, or have they actually done a very smart and well-structured query that's going to get the nominal minimum amount of data coming across the architecture in the backplane? We've got multi-tenancy workloads, multiple users and multiple groups running same or more multiple group workloads and batch jobs and real-time scheduling. And we've got this blend of batch and real-time processing. Some things just run regularly, hourly or daily or weekly or monthly. Other things are on demand. Someone might be sitting there with a tablet wanting to do a real-time report. And again, we come to that whole point that the complexity that comes about in these is not just a challenge now. It's quite frightening. And we have this reality check that a single performance issue, just one performance issue in its own right, can impact the entire ecosystem. And so we end up with this very fun challenge of finding out, well, where are the impacts? And we have this challenge of, are we being reactive or proactive? Are we watching the thing in real time and seeing something go bang and responding to it? Or have we seen some form of trend and realized that we need to proactively get on board with it? Because the key is everyone wants something fast and cheap and easy. But we end up with these scenarios of what I like to refer to in my favorite line of the old Donald Rumsfeld conundrum, which in my mind applies in all of these scenarios of high complexity, and that is that we have known knowns because there's something we design and build and it runs as planned. We've got known unknowns, and those we don't know who's running what, when, where, if it's on demand. And we've got unknown unknowns, and they're the things that we need to be monitoring and checking for. Because the reality is, we all know you can't manage something you can't measure. So, to have the right tools and the right capability to monitor CPU scheduling, look for wait times, find out why things are having to wait in scheduled queues in pipelines, what's happening in memory, what sort of utilization is being performed, what sort of performance we're getting out of memory, is stuff being partitioned correctly, it's being distributed, do we have enough nodes holding copies of it to cope with the workloads that are being thrown at it, what's happening with process execution away from the operating system processes, the jobs themselves running, the individual apps and the daemons supporting them, what's happening inside those processes, particularly the structuring of queries and how those queries are being executed and compiled, and the health of those processes all the way up the stack. You know, again, back to wait times. Is it scheduling correctly? Is it having to wait? Where is it waiting? Is it waiting for memory reads, I/O to the CPU, I/O across the network to the end user? And then back to that point I just mentioned just quickly before I wrap up, and that is how are we approaching issue resolution and response times to those? Are we watching it in real time and reacting to things, which is the least ideal scenario, but even then, it's better we do that than not know and then have the help desk call and say something went wrong, we've got to track it down? Or are we doing it proactively? And are we looking at what's coming down the line? So in other words, you know, are we seeing that we're running short of memory and need to add more nodes? Are we doing trend analysis? Are we doing capacity planning? And in all of that, are we monitoring historical execution times and thinking about capacity planning, or are we watching it in real time and proactively rescheduling and doing load balancing? And are we aware of the workloads that are running in the first place? Do we know who's doing what in our cluster and why? In-memory compute is very powerful, but with that power, it's almost one of those things like a loaded gun and you're playing with live ammo. You can eventually shoot yourself in the foot if you're not careful. So that power of in-memory compute just means that we can run lots more and quickly across very distributed and discrete data sets. But that then has a higher demand being driven from end users. They get used to that power and they want it. They're no longer expecting that jobs take weeks to run and reports turn up and fan old paper. And then underneath all of that, we have the day-to-day maintenance and so forth around patching, updates, and upgrades. And if you think about 24/7 processing with in-memory compute, managing that data, managing the workloads across it, it's all in memory, technically an ephemeral platform. If we're going to start applying patches and updates and upgrades in there, that comes with a whole range of other management monitoring challenges as well. We need to know what we can take offline, when we can upgrade it, and when we bring it back online. And that brings me to my final point, and that is that you know, as we get more and more complexity in these systems, it isn't something that a human can do just by sucking their thumb and putting the air anymore. There are no sort of you know, gut feeling approaches anymore. We really do need the appropriate tools to manage and deliver this high level of performance in compute and data management. And with that in mind, I'm going to hand over to our friends from IDERA and hear how they've approached this challenge.
Thank you very much. I am sharing out my screen. And here we go. So it's really humbling to just consider all of the technology and all of the people who came before us to make this stuff that's available in 2017 available. We're going to be talking about workload analysis for SAP HANA. It's basically a database monitoring solution. It's comprehensive, agentless, provides real-time, and it builds out a history. And so you can see what has happened in the past. SAP for HANA offers the potential of better, faster, and cheaper. I'm not saying it's inexpensive, I'm just saying it's less expensive. Kind of traditionally what happened was that you would have a main production instance probably running on Oracle in a larger shop, potentially SQL Server. And then you would use that ETL process and you would have multiple kind of versions of the truth. And this was very expensive because you were paying for hardware, operating system, Oracle license for each of these individual environments. And then on top of that, you would need to have people to reconcile one version of the truth to the next version of the truth. And so this multiple version ETL processing was just slow and very, very, very cumbersome. And so HANA, basically one HANA instance can potentially replace all of those other instances. So it's less expensive because it's one hardware platform, one operating system, instead of multiples. And so the S4HANA really, it does change everything. And you basically are looking at the evolution of SAP from R2 to R3 the various enhancement packs. Now, the legacy system is available until 2025, so you have 8 years until you're really forced to migrate, although we see people dabbling their toes into this because they know it's coming, and eventually, ECC will be running on HANA, and so you really need to be prepared for that and understand the technology. So one database, no ETL processes, no copies that must be reconciled. So once again, faster, better, and cheaper. HANA is in memory. SAP supplies the software. You supply the hardware. There's no aggregate tables. One of the things that they kind of suggest when you're kind of thinking about this is you don't want to get into this, hey, we're just going to buy the very largest server that's available. They suggest that you, in essence, kind of right-size your SAP landscape ahead of time. And they basically say, do not migrate 20 years worth of data. I think archiving is something that's underutilized in IT kind of across the board, not just in SAP shops. And so the next thing is that SAP has actually spent a lot of time rewriting a lot of their native code to not use select star. Select star returns all of the columns from a table, and it's particularly expensive in a columnar database. And so it's not a good idea for SAP HANA. So for shops that have a lot of customization, a lot of reports, this is something you're going to want to look for, and you're going to want to specify column names as you progress to migrating everything to HANA. We like to say that HANA is not a panacea. Like all databases, all technologies, it needs to be monitored, and as mentioned earlier, you need numbers in order to manage successfully, management by measurement. And one of the things that I talk about, in the IDERA area is that every business transaction interacts with the system of record, and in this case, it's going to be HANA. And so HANA becomes the foundation for performance of your SAP transactions, the end user experience, and so it's vital that it be kept running at top speed. It does become a single point of failure, and in talking to folks, this is something that can crop up where you have an end user that maybe is using that real-time data and they have an ad hoc query that potentially isn't quite right. Maybe they're not joining tables, and they've created an outer join, a Cartesian product, and you're basically consuming a lot of resources. Now, HANA will recognize that eventually and kill that session. And so there's a crucial part of our architecture that's going to allow you to actually capture that in the history so you can see what has happened in the past and recognize those situations. So let's take a look at the workload analysis for SAP HANA. This is version 1, so we are very much inviting you to join us in the journey, and this is a product from IDERA. It's comprehensive yet simple, real-time with trending, host health, instance health. We track the wait states, the SQL queries, memory consumers, and services. So this is what the GUI looks like, and you can see right off the bat that it's web-enabled. I'll actually open up this solution running live on my system. There's some crucial things you want to take a look at. We've kind of subdivided into different workspaces. Probably the most crucial one is what's happening at the host level from a CPU utilization and memory utilization. You definitely don't want to get into a swapping or thrashing standpoint. And then you basically kind of work your way down into what's happening in trending, from response time, users, SQL statements. That is what's driving the activity on the system. One of the things with IDERA is that nothing happens on a database until there's activity, and that activity are SQL statements that come from the application. So measuring the SQL statements is absolutely vital to being able to detect root cause. So let's go ahead and drill in. So at the host level, we can actually take a look at memory, tracked over time, host CPU utilization. Step back. We can look at the top SQL statements. Now, one of the things you're going to see in our architecture slide is this information is stored off of HANA. So if something were to happen to HANA, we're basically capturing information, up to, God forbid, an unavailability situation. We're also can capture everything that happens on the system so you have clear visibility. And one of the things that we're going to do is we're going to present the SQL statements in weighted order. And so that's going to take into account the number of executions. And so this is the aggregated resource consumption. And so you can get into individual metrics here. When did that SQL statement execute? And then the resource consumption is largely driven by the execution plan. And so we'll be able to capture that on an ongoing basis. HANA is in memory. It's highly parallel. It does have primary indexes on every table. Some shops choose to build a secondary index to address certain performance issues. And so kind of knowing what happened with the execution plan for certain SQL statements can be very, very valuable. We'll also look at the services, memory consumption, once again, charted over time. The architecture. So this is a self-contained solution that you can download from our website. And the architecture is that it's web-enabled. You can have multiple users connect to a particular instance. You can monitor multiple instances of SAP HANA. And we keep a rolling 4-week history in our repository, and that's self-managed. To deploy this, it's rather simple. You need a Windows server. You need to download it. Most Windows servers will have a built-in .NET framework, and it comes bundled with a license. And so you would go to the installation wizard, which is driven by setup.exe, and it would actually open a screen, license agreement, and you simply work down this outline by clicking next. And so where would you like HANA to be installed? Next is database properties. And this is going to be your connection to the SAP HANA. So this is agentless monitoring of the HANA instance. And then we basically give you a little preview. This is the port that we communicate on by default. Click install, and it basically starts up HANA, and you begin building the history. So just a little bit of a sizing chart information. We can monitor up to 45 HANA instances, and you'll want to use this kind of on a sliding scale to determine the number of cores, memory, disk space that you'll need. And this assumes that you have a complete 4-week rolling history going in. So just as a quick recap, we're looking at server health, instance health, CPU memory utilization. What are the memory consumers? What are the activity drivers? What are the services? SQL statements are vital. What are the execution states? Show me the execution plans. When did things execute? Provide trending. This is going to give you real time and a history of what had happened. And as I mentioned, because our history is separate from HANA, we're going to capture stuff that is timed out and had been flushed from HANA's history, and so that you can see the true resource consumption on your system because of that separate history. So as I had mentioned, IDERA's website, under products, you can easily find this. There is if you want to try this out, you're certainly welcome to. See how it provides information for you, and there's additional information on that website. So any interested parties are more than happy to go into that. Now, in the portfolio of products offered by IDERA, there's also an SAP ECC transaction monitor, and this is called Precise for SAP. And what it does is, whether you're using Portal or just straight up ECC, it will actually capture the end user transaction from click to disk, all the way through down into the down to the SQL statement and show you what's happening. Now, I'm showing you just one summary screen. There's a couple of takeaways that I want you to have from this summary screen. Is the y-axis is response time, the x-axis is time across the day, and in this transaction view, we'll show you client time, queuing time, ABAP code time, database time. We can capture end-user IDs, T-codes, and you can actually filter and show servers the particular transaction traversed. And so many shops run the front end of a landscape under VMware, so you can actually measure what's happening on each of the servers and get into very detailed analysis. So this transaction view is for the end user transaction through the entire SAP landscape. And you can find that on our website under Products APM Tools, and this would be the SAP solution that we have. The installation for this is a little bit more complicated, so it's not just download and try it like we have for HANA. This is something where we would work together to design and implement the overall transaction view. So just as a very quick recap, workload analysis for SAP HANA, it's comprehensive, agentless, real-time, offers a history. We offer the ability to download and try it for your site. So with that, I'm going to pass the baton back to Eric, Des, and Dr. Bloor.
Yeah, maybe Robin, any questions from you, and then Des after Robin?
Okay, I mean, the first thing I'd like to say is I really like the transaction view because it's exactly what I would want in that situation. I did a little work, it was a long time ago right now, doing performance monitoring, and that was the kind of thing, we didn't have the graphics in those days, but that was the kind of thing I particularly wanted to be able to do, so that you can in one way or another inject yourself into wherever the problem is happening. So the first question I have is, you know, most people are implementing S4 in some way or other out of the box, you know. When you do when you get involved in a given implementation of S4, do you discover that it's been implemented well, or do you end up, you know, discovering things that might make the customer want to reconfigure? I mean, how does all of that go?
Well, every shop is a little bit different, and there's different usage patterns. There's different reports. For sites that have ad hoc reporting, that's actually kind of like a wild card on the system. And so one of the crucial things is to begin measurement and find out what the baselines, what's normal for a particular site. Where's the site, that particular site, based upon their usage patterns, stressing the system, and then make adjustments from there. Typically, kind of the monitoring and optimization is not a one-time. It's really an ongoing practice where you're monitoring, tuning, honing, making the system better for the end-user community to be able to serve the business more effectively.
Okay, so when you implement, how much? I mean, I know this is a difficult question to answer because it's going to vary depending on size of implementation or something. But how much resource does the IDERA monitoring capability? How much does it consume? Does it make any difference to anything, or is it just doesn't kind of interfere? How does that work?
Yeah, I'm going to say that the overhead is approximately 1 to 3%. Many shops are very much willing to sacrifice that because, you know, potentially you'll be able to buy that back in terms of optimization. It does depend upon usage patterns. If you're doing a full landscape, it does depend upon the individual technologies that are being monitored. So, you know, kind of mileage does vary. But like we kind of talked about, it's definitely better to spend a little bit to know what's going on than to just run blind. Particularly when here we are in January, and you get into like year-end processing, and you're aggregating 12 months worth of data. that's when performance, getting reports out to regulatory organizations, to banks, to shareholders is absolutely vital and a critical business performance.
Right, and just a quick, from your perspective, because I guess you're out there involved with a whole series of SAP sites. How big is the movement amongst the SAP customer base towards S4? I mean, is that something that is being, that there's a kind of an avalanche of enthusiastic customers going for it, or is it just a steady trickle? I mean, how do you see that?
Yeah, so I think a couple years ago, I would say it was a toe. Now I'd say that people are kind of up to their knee. I think that, given the timeline, people are going to be really immersed in HANA over the next couple of years. And so the monitoring, the transformation, I think that the majority of customers are kind of on the learning curve together. And so I think we're not quite at the avalanche as you had stated, but I think we're on the cusp of the major transformation over to HANA.
Okay, so in terms of the sites that you've seen of gone for this, are they also adopting HANA for other applications, or are they, in one way or another, kind of completely consumed with making this stuff work? What's the picture there?
Yeah, so oftentimes people will integrate SAP with other systems, depending upon what modules and so forth. So there's a little bit. I don't really see people deploying other applications on HANA just yet. That's certainly possible to do. And so it's more around the landscape around the SAP infrastructure.
Right, I suppose I better hand you on to Des. I've been hogging your time. Des?
Thank you. No, that's all good. Two very quick ones just to try to set the theme. SAP HANA has been out for a couple of years now, and people have had a chance to consider it. If you were to give us a rough estimate of the percentage of folk that are running it, because I mean there are a lot of people running this stuff. What do you think the percentage of the market that you're aware of is currently that have gone from just traditional SAP implementations to SAP on HANA? Are we looking at 50-50, the 30-70? What sort of percentage of the market are you seeing of people have transitioned and made the move now versus folk who are just holding back and waiting for things to sort of improve or get better or change or whatever the case may be?
Yeah, I'd actually put, from my perspective, that I put the percentage around 20%. SAP tends to be traditional businesses. People tend to be very conservative, and so people will drag their feet. I think it also depends upon have you been running SAP for a long time, or are you kind of an SMB that maybe have more recently deployed at SAP, and so there's kind of a number of factors, but overall, I don't think the percentage is 50-50. I would say that 50% are dabbling, or at least dabbling, and have HANA running somewhere in their data center.
The interesting takeaway that you gave us earlier on was that this is a fait accompli in a sense, in that there are the clock is physically and literally ticking on the time to transition. In the process of doing that, do you think people have considered that? Or, what's the general sense of folk understanding that this is a transitional shift in platform? It isn't just an option; it's becoming the default, and that from SAP's point of view, I'm sure they're pushing that way because it's a significant competitive advantage in performance, but it's also I guess they're wrestling control back of the platform instead of it going to a third-party database. They're now bringing it back to their own platform. Do you think companies have actually gotten that message? Do you think people understand that and are now gearing to it, or is it still sort of an unclear thing, do you think, out in the market?
I do not think that SAP is shy about communicating, and people who've gone to Sapphire have seen HANA everywhere. So
right.
I think people are well aware, but, you know, human nature being what it is, you know, some people, you know, kind of dragging their feet a little bit.
I think the reason I was asking that question, sorry, and you'll have to forgive me for this, is that I agree. I think you know, they haven't been shy about communicating it. I think that the signal's gone out as in many ways, and I agree with you. I don't know that everyone's jumped yet. You know, traditional enterprise, very large enterprises that are running this are still in many ways not so much dragging their feet, but just trying to grapple with the complexity of this shift. Because I think the one thing that your tool and certainly your demonstration today has highlighted, and for me, one key takeaway I'd like everyone listening and tuned in today to kind of sit up and pay attention to respectively is you've got a tool now that simplifies that process in my mind. I think it's a, you know, there's a bunch of very nervous CIOs and their teams under them who are sort of thinking, how do I make the transition from traditional RDBMS, relational database management systems that we've known for decades, to a whole new paradigm of compute and storage management in a space that is still relatively brave in my mind, but it's an unknown in many ways. You know, very few people sort of made that shift in other areas. It's not like they've got another section of the business that's already made a move to memory compute, so it's an all or nothing move in their minds. So one of the things I've taken away from this more than anything, and I'm going to hit you with a question in a minute, is that fear now, I think, is allayed in many ways, and that prior to today, if I was a CIO listening, I would sort of think, well, how am I going to make this transition? How am I going to guarantee the same capability that we've got in the relational database management platform and years of experience with DBAs to a new platform that we don't currently have the skills in? Do you think, so my question with that is that, do you think people have understood that the tools are there now with what you're offering, and that they can kind of take a deep breath and sigh of relief that the transition isn't as scary as it might have been prior to this tool being available? Do you think people have kind of understood that, or is it still kind of a thing that they're just grappling with, you know, the transition to in-memory compute and in-memory storage versus old school sort of, you know, combinations of NVMe and flash and disk?
Yeah, so there's undoubtedly a lot of technology and tools that, you know, can graphically display this, what's happening, and make it very easy to pinpoint top resource consumers. I mean, it does help to simplify things. It does help the technology staff really get a good handle that, hey, they're going to be able to know what's going on and be able to kind of understand all of the complexity. So absolutely, the tools in the marketplace are definitely helpful, and so we offer workload analysis for SAP HANA.
Yeah, I think the great thing about what you've shown us today is that, you know, monitoring the hardware piece, the operating system piece, even monitoring some of the workload moving through, as you said, you know, the tools have been there for some time. The bit for me, particularly inside the likes of HANA, is that we haven't necessarily had the ability to get a magnifying glass and peek into it and see right down to what your tool does with what's happening with the queries and how they've been structured and where that load is. With the deployments you've seen so far, given that you are quite literally the most authoritative in this space in your platform in the world, some of the quick wins that you've seen, have you got any anecdotal knowledge you can share with us around some of the eureka moments, the aha moments where people have deployed the IDERA tool set, they've found things that they just weren't aware were in their platforms and performance hits they've had? Have you got any great anecdotal examples where people just deployed it, not really knowing what they've had, and all of a sudden going, wow, we actually didn't know that was in there?
Yeah, so a big limitation of the native tools are that if a runaway query is canceled out, it flushes the information, and so you basically don't have the history. By us storing the history offline, you know, like a runaway query, you'll have a history, you'll know what had happened, you'll be able to see, you know, execution plan and so forth. And so that allows you to, you know, kind of help the end user community, you know, basically operate better, write reports better, et cetera. And so the history is something that's really nice to have. And, one of the things that I had meant to kind of show is that you can look at real time up to 4 weeks, and then you can easily zoom in on any time frame of interest, and then you can expose the underlying driving activity. And just having that visibility is something that's very helpful to know what bottlenecks had arisen.
You mentioned it's multi-user. Once it's deployed, and I was quite impressed by the fact that it's agentless and effectively zero touch in many ways. Is it normal for a single deployment of your tool to then be available to everyone from the network operating center in the NOC watching core infrastructure underpinning the cluster, all the way up to the application and development teams? Is it the norm that you deploy one instance and they would share that, or do you anticipate people might have multiple instances looking at different parts of the stack? What does that look like?
So, the basis team will typically have a very strong interest in the technology underpinnings of what's happening in SAP. Obviously, there's multiple teams that will support the entire landscape. The HANA piece, which is focused on that, we'll be looking at, that. I'm going to just default to the SAP basis team as the primary consumers of the information.
Right. It strikes me, though, that if I've got a development team, or not even just at the code level, but if I've got a team of data scientists or analysts doing analytical work on the data sets in there, particularly given that there's a significant push to data science being applied to everything inside our organizations now. In my mind, and correct me if I'm wrong, it seems to me that this is going to be of great interest to them as well, because in many ways, one of the scariest things you can do in an enterprise data warehouse environment is unleash a data scientist upon it and allow them to start doing ad hoc queries. Have you had any sort of examples of that kind of thing happening where shops have rung you and said, look, we're throwing a data science team that think it's really hurting, what can we do for them versus what we're doing in just traditional operational monitoring and management? Is that even a thing yet?
Well, yeah, I kind of turn this a little bit, and my reply would be that looking at performance, being performance aware in development, QA, production, the sooner you start, the less problems, the less surprises you have. So
right.
Absolutely.
So flowing on from that, a lot of the tools that I've had experience with, and I'm sure Robin would agree, a lot of the tools here, if you've got a large RDBMS, you need really, really high skilled, deeply knowledge, experienced DBAs. Some of the infrastructure and platform requirements that come around with SAP HANA, because it's only supported on particular distributions of Linux, on particular hardware and so forth, to the best of my knowledge. There's people with decades of experience thrown at this thing. What I'm seeing, though, is that isn't necessarily the requirement with this tool. It seems to me that you could deploy your tool and give it to some fairly new faces and give them the power straight away to find things that aren't performing well. Is it the case that there's a pretty short learning curve to get up to speed with this and get some value out of deploying it? My general sense is that you don't have to have 20 years of experience of driving a tool to see the value immediately. Would you agree that's the case?
Absolutely. And, to your point, I think that a lot of the success of a deployment really depends upon the planning and architecting of the SAP HANA environment. And then, there's undoubtedly a lot of complexity, a lot of technology is built on, but then it just comes down to monitoring the usage patterns of what's happening. So there is, although it's more complex, in a way it's packaged and somewhat simplified. That's a very broad statement.
Yeah. So before I hand back to Eric, because I know he's got a couple of questions, particularly from some that's come through Q&A, which looked interesting, that I'm keen to hear the answer on. Traditional journey for someone to, you mentioned earlier that you can get it, you can download and try it. Could you just recap on that quickly for folk listening either today or folk who might replay it later? What are the quick 2 or 3 steps to get their hands on a copy and deploy it and try it in their environments before they buy it? What does that look like? What are the steps for that?
Yeah, so IDERA.com and just go to products and you'll see Workload Analysis for SAP HANA. There is a download page. I think they'll ask you for some contact information, and the product is just packaged with a license key, so you can install it with the setup exe and just get rolling, I think, very quickly.
So they can go to your website, they can download it. I remember looking at it some time ago, and I double-checked last night as well. You can request a demo from memory with someone on your team will sort of walk you through it, but you can actually download it for free and deploy it locally in your own environment in your own time, can't you?
Yes.
Excellent. Well, look, I think more than anything, that's probably the thing that I would personally advise folks to do is grab a copy off the website, grab some of the documentations there, because I know there's a lot of good content there to do that with. And just try it. Put it in your environment and see what you find. I suspect that once you have a look under the hood with your SAP HANA environments with the IDERA tool, you're going to find things that you actually weren't aware are in there. So, look, thank you so much for that, and thanks for the time just for the Q&A with Robert and I. Eric, I'm going to pass back to you because I know that some Q&A has come through from our attendees as well.
Yeah, just a real quick one here. So one of the attendees makes a really good comment here, just talking about how things are changing. Saying, in the past, memory was choking, slowing down by frequent paging. Currently, CPU is choking with too much in-memory data. There are network problems. It's always going to be a moving target, right? What do you see as the trajectory these days in terms of where the bottlenecks are going to be and where you're going to need to be focusing your attention?
Yeah, so until you measure, it's hard to know. One of the things about the SQL statements is they are going to be the drivers of resource consumption. And so in the circumstance that you were to have like a large memory consumption or CPU consumption, you'll be able to figure out what activity caused that resource consumption. Now, you wouldn't necessarily want to kill it, but you also want to be aware of it and kind of what's happening, how often does it happen, et cetera. We're kind of still new in terms of addressing kind of all of the whole set or cookbook of responses to different circumstances, and so it's a great question, and time will tell. So we'll have more information as time passes.
That's it. Well, you guys are in a very interesting space. I think you're going to see a lot of activity in the coming months and next couple of years, because I do know that SAP, as you suggested in our content call, has provided a nice long on-ramp for folks to make the transition to HANA, but nonetheless, that ramp does have an ending, and at a certain point, people are going to have to make some serious decisions, so the sooner the better, right?
Absolutely.
All right, folks, we burned through another hour here on hot technologies. You can find information online, InsideAnalysis.com, also Techopedia.com. Focus on that site for lots of interesting information, including a list of all of our archives of these past webcasts. But, folks, big thank you to all of you out there, to our friends at IDERA, to Robin, and, of course, Des. And we'll catch up to you next week, folks. Thanks again for your time and attention. Take care. Bye-bye.